Okay, we're going to move on to our next section of Chapter 8. Okay, in our next section of Chapter 8, Section 8.3, what we're going to be taking a look at is what we want to do is to simplify what we call a complex fraction. Now, it sounds more complicated than it really is. Okay, don't be intimidated by the terminology of a complex fraction. All right, sometimes people don't like fractions to begin with, and then when we throw the adjective of complex in front of it, that really gets us concerned. Okay, but what we're going to do first, let me show you an example using strictly numbers, and then we will use a similar approach with the algebraic fractions, the rational expressions. So let's say we have 1/2 plus 1/3 over 3 minus 5/4. Now this is an example of what we classify as a complex fraction. Really what we have here is smaller fractions found within the much larger fraction. Okay? And what I'm going to show you is there is a way that we can simplify this complex fraction by getting rid of all of the much smaller fractions. We have the small fraction of 1/2, 1/3, 5/4, and even we can think of this as 3/1. So we have these four fractions that we want to eliminate all of these smaller ones and just have the much bigger fraction. And the way to do that is to identify that lowest common denominator. We used a similar idea of identifying the lowest common denominator when we were adding and subtracting fractions. Okay, so what we want to do is we want to look at the denominator of 2, the denominator 3, the denominator 1, and the denominator 4. And we are trying to come up with the smallest number possible that will be divisible by the 2, 3, 1, and 4. And the smallest number that comes to mind is the number 12. Okay, 12 is the smallest number that is divisible by 2, 3, 1, and 4. Okay, evenly. There are other larger numbers, okay, 24, 36, 48, 60. Actually, those are all the multiples of 12. But 12 is the smallest number that is divisible by those four denominators. And what I'm going to do is I'm going to multiply by the form of 1, 12 over 12. Okay? So I want to multiply the numerator by the 12, and I want to multiply the denominator also by 12. Okay? This will clear the fractions. Okay? This will clear all of the smaller fractions. So now let's do that. Let's multiply 1/2 times the 12. And half of 12 is 6. Then there's the plus sign. Now I need to take 1/3 of 12. And if I take 1/3 of 12, I get, of course, the number 4. So that cleared the fractions that were in the numerator. Now let's see what happens when I take, and I have to multiply now the fractions that are in the denominator also by 12. 3 times 12, that's just, of course, 36. Then there's the minus sign, just like we have here. And 5/4 of 12, well, 5/4 times 12, that, of course, would be 15. So now I cleared all the smaller fractions that were in the numerator. I cleared the smaller fractions that were in the denominator. And I am left with just 6 plus 4, which is 10. And then if I take 36 minus 15, we get 21. So this is a simplified equivalent fraction to this complex fraction. Okay? What did we do? In essence, we multiplied by the form of 1. 12 divided by 12. All I'm doing is taking this complex fraction, multiplying it by a form of 1, a very unique form of the number 1 that puts the lowest common denominator over itself. And when you perform that multiplication by the number 1, that form of 1, you get an equivalent simplified fraction with no more little fractions. Okay? Now we're going to do a similar approach when it comes to the algebraic fractions. For example, let's take 2 over x plus 1 over x plus 6 over 4 over x plus 6 minus 1 over x. Here we have, now don't be intimidated by this, here we have a algebraic complex fraction. Okay, let's take a look at the denominators. I have a denominator of x. I have the denominator x plus 6. I have the denominator x plus 6, and I have another denominator of x. Now recall what I had said that the other day. To find the lowest common denominator, each different denominator needs to be represented. So I have the denominator of x. That needs to be accounted for. But then I have a different denominator, x plus 6. That also needs to be accounted for. So my lowest common denominator is made up of each different denominator. It must have the x's, and it must have the x plus 6. Now once again, I want to clear these much smaller fractions. So I have to multiply the numerator and the denominator by this lowest common denominator. X times x plus 6 and x times x plus 6. Now, we have to multiply each of these fractions with the lowest common denominator. Now remember, if something is the same top and bottom, it will simplify. So, if I multiply the 2 over x with the x times x plus 6, the x that's in the numerator and the x that's in the denominator will simplify with each other, okay? And what remains, there's still a 2, and there is still the x plus 6 left over. Okay? That's what you get when you multiply this fraction with the lowest common denominator. Once again, let me repeat that. The x that's in this numerator and this x that's in the denominator would simplify. Okay? It's going to go away. What remains is the 2 I put here and the x plus 6 I put here. Then there's a plus sign, so let me put that in. Next, I have to multiply the 1 over x plus 6 with the lowest common denominator. And the x plus 6 that's in the numerator will simplify with the x plus 6 that's in the denominator, and what remains is the 1x. So I cleared the smaller fractions that were in the numerator. But now I have to do the same thing with this denominator. I have to multiply each of these fractions with the lowest common denominator. And let's do this carefully. If I multiply the first fraction, 4 over x plus 6, with the lowest common denominator, the x plus 6 that's in the numerator and the x plus 6 that's in the denominator will simplify. Will simplify out, and what remains is the number 4 and the x. Then there's a minus sign. Next, let's multiply the 1 over x times the lowest common denominator, and once again the x that's in the numerator will simplify with the x that's in the denominator, and when we simplify those terms, what remains is the 1 and the x plus 6. So now, once again, we cleared all the smaller fractions that were found in this problem. But now we want to simplify what we can. In my numerator, what I want to do, let's see what I can do here. In my numerator, I would want to distribute my 2. And when I do that, I get 2 times x, or 2x. 2 times the 6, we get a plus 12, plus the 1x. In the denominator, I would like to distribute this negative 1. When I do that, we have 4x minus the 1x minus the 6. So now let's see what I can do here. Now that I did my distribution, I would like to combine my like terms. I have in the numerator the 2x plus the 1x. That, of course, would give us a 3x plus 12 over. In my denominator, I have 4x minus 1x. That, of course, would give us 3x minus 6. Can I simplify this fraction? Sure. Remember how we simplify rational expressions, algebraic fractions. We look to do any and all factoring that's possible. Well, in the numerator, I can factor out a common factor of 3. And if I factor out a 3 from these two terms, we would be left with an x plus 4. When I look at the denominator, I can also factor out a greatest common factor of 3, and that would leave me with an x minus 2. See, that skill of factoring is coming back to haunt us a little bit. And now that we have the factored form, we know that we can simplify this even further. In that, the 3 that's in the numerator and the 3 that's in the denominator, since they are the same factors being multiplied, we can further simplify those, now leaving us with an x plus 4 over the x minus 2. And that would be your simplified answer. Okay? A lot of steps here that you do have to be careful of, because the more steps that we have, the more room for some small errors that can be made. Okay? But the process that we took is pretty much the same as we did with the first example. We identified what the lowest common denominator was. We then have to multiply the numerator and the denominator by that lowest common denominator. Remember, this does not change the value of this fraction. It just changes the way it looks. Because in essence, remember, all you are multiplying here by is a very fancy form of the number 1. When we did the multiplication, we were left with some expressions in the numerator and the denominator that we were able to further simplify, using, of course, the distribution property and the combining of like terms. Once you have your fraction, you look to see if you can further simplify by once again performing factoring. Okay? Let's try one more. Okay? Let's say, for example, we have the number 1 minus 4 over x plus 5 over 4 over x squared minus 25 plus x over x minus 5. Now, this one's a bit more challenging, okay? Because initially, I notice, looking at my denominators, I have a denominator of 1. I have a denominator of x plus 5. I have a denominator of x minus 5. And then I have this denominator of x squared minus 25. Now, that should sound familiar. This x squared minus 25 polynomial can be factored. And if we have something that is factorable, you want to factor first, because that will help you identify the lowest common denominator. So I'm going to leave the top as it was, 1 over 1 minus 4 over x plus 5 over 4 over. Now this polynomial, I'm going to factor it down because I know it to be x plus 5 times x minus 5. Plus, now we have this last fraction, x over x minus 5. So factor any polynomial in your denominator first, okay? Because that will now help us identify what is the lowest common denominator. Okay, so let's do that. The lowest common denominator is made up of each different factor that's in the denominator. So we have a denominator of 1, but we don't really need that because when you're multiplying by 1, it's not going to affect it. I have this denominator of x plus 5. It's the same as this denominator of x plus 5, so we're not going to repeat it. I have a denominator here of x minus 5 that's different, so we have to include it in the lowest common denominator. And we have the x minus 5 also represented already. So your lowest common denominator, once again, is made up of each different denominator. So I have the different denominator factors of x plus 5, as well as the different factors of x minus 5. Now remember, what we have to do to clear these smaller fractions is I'm going to multiply now both the numerator and the denominator by the lowest common denominator, which once again is x plus 5 times x minus 5. That's the form of 1 that we have to multiply our complex fraction by. Let's see what this is going to give us. When I multiply the number 1 with the lowest common denominator, we're going to get the lowest common denominator, x plus 5 times x minus 5. That's what we got when we multiplied the 1 with the lowest common denominator. Then there's a minus sign, so let's put that in. Next, I have to multiply this fraction with the lowest common denominator. And what, of course, happens is the x plus 5 that's on the top will simplify with the x plus 5 that's in the bottom. And what happens, what remains, is the 4 as well as the x minus 5. So that cleared the fractions in the numerator. Now let's go and do the same thing with the denominator. I have to multiply this fraction with the lowest common denominator. And when I multiply this fraction with the lowest common denominator, both x plus 5s as well as x minus 5s will simplify, and what truly remains is just the number 4. Then there's a plus sign. Now I have to multiply this fraction of x over x minus 5 with the lowest common denominator. And when we multiply these together, the x minus 5 that's in the numerator and the x minus 5 that's in the denominator will simplify, and what remains is the x and the x plus 5. Okay. So we cleared out all of the smaller fractions. But now we have to simplify what's in the numerator, and we need to simplify what's in the denominator. So let's do that. In the numerator, we're going to have to multiply these together, as well as I will distribute my negative 4. Okay? When I do that, if I multiply x plus 5 times x minus 5, we in fact get x squared minus 25. And when I distribute the negative 4, that would give us a negative 4x and a plus 20. In the denominator, I will distribute my x. So now I have 4 plus x squared plus 5x. That was all the multiplication. Now, of course, what I will do is combine any and all like terms. Excuse me. In the numerator, we have the x squared. I have the negative 4x, as well as I have the negative 25 plus 20. Those are like terms that I can combine, and that would give me a minus 5. So that takes care of my numerator. Now the denominator, all I'm going to do is I'm going to write it in descending order. Now, where have I heard that before? Putting something in descending order of x squared plus 5x plus 4. Because now I'm going to look at this rational expression, this algebraic fraction, and I want to see if I could simplify this rational expression. And of course we can, using our favorite skill, the skill of factoring. And so now let's factor this down. The numerator would factor down x and x. We need different signs, plus, minus. And of course the factors of a negative 5 that would add up to a negative 4 would have to be a positive 1 and a minus 5. Similarly with the denominator now, I'm going to set up my parentheses. The factors of x squared, x, and x. Except now I need the same sign. I need two positive numbers. And the two positive numbers that will multiply to 4 and add up to the number 5, of course, would be 1 and 4. Now that we have the fully factored form of the algebraic fraction, as always, we look to see if we can simplify using that fundamental principle of fractions, and sure enough we can. The x plus 1 in the numerator and the denominator simplify, and what's left is the x minus 5 over the x plus 4, and that is your answer there. Okay, so we had to begin the problem by factoring, and we had to end the problem with factoring as well. Okay, so make sure that you have a firm handle on your factoring skills, as they play an important part throughout Chapter 8 as well as Chapter 7. Okay, that will complete Section 8.3, the simplifying of complex fractions. Do take a look at the homework that goes along with the section, and feel free to email me any questions that you may have about this or any other section for that matter. Until the next time, be well.